Hello, welcome to New Data. Today we're going to talk about SQL, views, pipelines and copying and Parquet files, and do some practical examples on how you might achieve delivering a simple outcome using only those three components. So, as always, our examples are based on Synapse Analytics, SQL on Demand, Spark pools, and pipelines and data flows in Synapse. And our storage is always Azure Data Lake 2. So let's just go through what I'm going to show. So SQL on Demand, serverless to read from and query some JSON files. We're going to save that query as a database view. We're then going to create a pipeline to copy the rows from the query to files in a destination file. Doing so, we're going to convert the JSON data to Parquet. We're going to compact the data from being lots of simple individual files for each row in each piece of JSON. And we're going to also add compression. We're going to create a materialized view. It's actually no different than creating another view, but there's a reason for doing that. And then we're going to update the pipeline to consume the materialized view, to perform a transformation, and then save the ultimate result as a data mart. So let's jump right into Synapse Analytics. And in this particular workspace, I've already navigated to the Data tab and then to the Linked Storage tab. I've then expanded the storage that I have connected. We won't go into how to connect storage, etc. to the workspace. There's plenty of tutorials that allow us to do that. And then we've got two containers connected to our storage. We have a primary container which actually brings in the Enterprise Data Hub folder, and then we have a landing container, and that's where I've got two folders. So in that landing container, I've got folders with dev data, and these are JSON files in here. Let's preview one of those JSON files. It's a fairly straightforward JSON file with some information, fictional information about cars. And then we've got what is our production data in this fictional system. So before starting, I know that the JSON in each of these files may not be the same. It's actually telemetry data, and it might be different. However, what we do know is that it is a valid piece of JSON. So the intention is going to be to create a table with a single column with the JSON packet in that column, so that we can do some later extraction. So let's right click on one of these files, and let's just select from that file using the wizard. As you can see, this writes us a select statement using the open row set command, and it's going to return for me just the JSON content from each file, and it's named the column JSON content. It's defined a schema, and it's given it a varchar max as its default way of returning text that's in that file. The interesting thing about the wizard is that it's configured itself to the data that we're trying to pull. Let's not focus too much for the moment on the fact that that's configured itself to CSV. For the purpose of what we're trying to do in this instance, that's okay. So if I run that query, I'm going to get back content for that one file because the path points directly to that single file. Double asterisk actually provides for a full wildcard in that directory, so it will go and find anything that matches or any file in that directory. So let's now run that command. and we'll see that we actually get returned all 26 rows. So So let's just have a look at this JSON, and we can see there's different formats on each row, and there's a particular format here where the JSON packet starts with an element called name. And let's just pretend for the moment that these are the ones that we're interested in, where it conforms to this format. We've got a struct, not an array. We've got a struct at the top level, or a map at the top level, and it has the element name. So just got a little bit of snippet of SQL that we can bring in, just a pre-written case statement. The case statement, all that's doing is checking that the column has valid JSON in it for a start, and then looks for that name element in that piece of JSON, and if there isn't that name element, it returns null. And here's the result. So what we want to do is we want to exclude all of the rows with null. So I've just got a little snippet of code here, which is basically the copy of my case statement turned into a where clause. Let's give that a whirl. And we come back with only the rows that we're interested in, so where the packet contains the element name in the first top struct or map. Okay, so we've got two options to saving this work now. So we're going to do both. So the first option is that we can save this piece of work as a SQL script in the Synapse Analytics workspace. So that saves our code. So we're going to just call this find packets with name. And when you say saving this within the Synapse workspace, what we're actually doing is committing that to the Git repository that's attached to the Synapse workspace, which there's plenty of tutorials to tell you about that. If we want to navigate to where that is, we can find on the Develop tab, we can find that script now sitting inside SQL scripts. Cool. So the next step is, let's turn this into a view that we can call separately from and encapsulate this logic. So a view is really just saved SQL on a SQL server. Inside this workspace in the Data tab, I already have a database set up for the Synapse workspace with the same name. This is quite simple. You can create these from the menu, so we could create a new SQL database from the menu. For these types of TSQL views, we'll be using a SQL database. Data lake databases are connected to using Spark, and it's actually a technology called Hive, which we'll go into another time, but for the purpose of this simple pipeline, we're going to use a SQL database. Views sit underneath the Views tab. We have a couple of ways in which we can turn this into a view. The preferred tool, or my preferred tool, is to jump back to Sql Management Studio that we've been used to for a long time. Okay, Sql Management Studio, the friendly interface that we've been used to for probably close to 20 years now in the Microsoft SQL world. So I'm going to bring across the script that we've just written. And as you can see, I've already started the script with a create view syntax, creating a view called car swap packets. So that should be good to go now. We can press execute and we get a command successful. We can come to the Views tab on the right hand side here, and our new view is available, and we can select from our new view and we get our results back. Excellent. There's a couple of other things that we can do inside this tool. that not possible to do at this moment in Synapse through the web browser. We can actually create things like a create or alter script. The Sql Management Studio tool has this scripting wizard that allows us to do that. So we can always get the SQL back that's in our view via this method. They're yet to implement that feature within Synapse Studio. So I've just tidied this up a little bit to a very, very simple SQL script, and we've still got our same 7 rows being returned. So now our next aim is to copy those 7 rows into a Parquet file in an interim piece of our data lake. We tend to use a workspace folder for this. The folder naming is completely arbitrary. It's just about the way in which you're organizing yourself. Typically, the environments that I work on, we work with the names of source, workspace, and surface. So source being where data lands and is available for consumption. In this instance, you saw the folder landing. That's like a pre-source environment. So that's because we've got data streaming into a landing environment. So back in Synapse Studio now. So this was our original script. Let's just, before we move to starting a pipeline, let's come to the views inside that database, and we can see that our new view now exists here as well. We can also query that view here locally. So that produces the script, press run, and it will run the query against the data lake and bring us back the same rows. So you've just got 2 alternative ways in which you can interact with that database and the views from the 2 tools. It's not possible here to create the view script, but it is possible to do that through Management Studio. So the next step is, how are we going to consume this data and then write that data out as a Parquet file? Okay, so we're going to come to the Integrate tab, and we're going to create our first pipeline. So we're going to do the simplest pipeline, which is we're going to use a copy data transformation. So we bring the copy data transformation onto the work palette. So let's just give this a reasonable name, which is going to be car swap filter and compress. Okay, it doesn't like my end symbol. Okay, the copy data elements have 2 main configurations. So we need to get the data from somewhere, and then we need to sync the data to a destination. Microsoft's weird terminology aside, the next task is to configure the source so that we can run that view that we just created. So in this particular instance, I don't have any sources already pre-configured, so we're going to have to configure one. So from the menu, we're going to look for the SQL Azure database driver. And let's just, for the moment, we'll call this the car swap connection. We might use this connection for other connections with the same database. We actually already have a linked service. There's actually 2 layers going on here in Microsoft. So we've got a data set sitting between that copy job and the actual database connection. So we've already got a connection to the correct database server, which we've called main. This will also give us a set of tables. Tables or views are really classed as the same thing when you connect to SQL Server in this way. So we can see that view that we've created, and it's basically brought through to us as if it was a table. So let's say OK to that. that sets up a new data set and drops us into this configuration setting. Effectively at this point, it's not really necessary for us to alter any of these items. You might want to parameterize some of these in the future, and that can be done differently. Let's hit preview and let's see to make sure that we're going to get those same rows that we were expecting to get back. Okay, so the job now is to configure the source of where these rows are going to be written. And remember, our intention is to write these rows out as a Parquet file. So we have a link service, or we have a data set created of a type Sql. You can see that by the icon. What we actually need though is an output data set by the type Parquet. So when we write Parquet, what we're actually going to do is write to our storage. And our storage, in fact this is the same for all file formats that we write out. Our storage is ADLS2, Azure Data Lake Storage 2. So we'll select that. And then we get an option of different file formats that we can output in. We want to pick Parquet. So we'll just call this our car swap out file. We already have storage container set up for our default workspace storage, which is handy because this is the place where we want to store this interim file. So this Synapse tool actually provides us with a really interactive relationship with the storage, etc. And as you can see, this runtime is actually up and running, got a green tick next to it. We can hit this browse button and we can actually navigate via our storage account via the folders and the hierarchy. So let's pick the workspace folder. That's where we're going to drop these files. And let's press OK on that to set that up as a connection. Data set, an output data set. Excellent. So there's some configuration settings here. Much of this is for this purpose of this exercise. We don't have to worry about. You will come back here for large data sets, etc., to make configuration changes. Let's just have a quick peek at that connection. We might want to put those files into some kind of subfolder. So let's actually just edit this and put in a subfolder for car swap. So we're going to drop those files into a subfolder. Can you please notice here as well that we've already got by default snappy compression enabled. So the output of these files will drop as compressed Parquet files. So as per our previous example, the way to save this thing is to commit that to the repo. I'm just going to close that tab too, just to save confusion. So we've now got the source and the destination configured. There are other tabs within here, for example, mappings, settings, and some user properties if you need to set user properties yourself. We're not going to go into that level of sophistication at this point. So let's just recap. We're going to pull this data from this configuration and sync this data to this configuration. So it's from dataset A to dataset B. Those datasets actually sit here alongside the storage configuration. As you can see, the two datasets are here. So I think what we need to do is commit all of these back to the repository. So they're all saved. And this is probably time that we want to now give this a whirl and see what happens. So let's hit the debug. That's going to run what it can see in front of us inside Synapse Studio. You see we've been moved to the output element here. We've got the in progress status of this run, there is, well, that's already succeeded. There is a few little items here which are interesting. So if there were any features or any parameters passed into this pipeline, we would be able to see those here within this JSON packet that's pushed into. And also, if this pipeline pushed out any parameters, we could see those parameters coming out here from this tag on the pipeline. We can also see an overview of what happened during the pipeline. So we can say it read through 7 rows and it wrote 7 rows, which is exactly what we were expecting. So let's go and have a look at the data that's dropped. So we know it was in the EDH file system. We know that it was in the workspace folder. We've got our car swap folder sitting under that. And we now have a Parquet file. Noted the Parquet file has automatically been named the same name as the table from the source. Interesting. Maybe useful. There's a couple of ways we can look at this Parquet file. We could double click on that and download it and open it. We'd need a tool for that. Or we can come here and we can right click and we can do a SQL on demand query directly against that file. So you can see here this is directly against that particular file, and we can see we've got the desired output that we expected, the 7 rows within that Parquet file. So this script isn't quite what we would want for actual delivery. So let's remove this top 10. So if there ever ends up being more than a top number of rows, so we get every row, and let's also take away this named file, and let's change that to a star. That should allow us then to get any Parquet files that happen to exist in that folder as one. We'll also add a where clause. So we'll add a where clause to pull out only rows that meet this list all. So where name is equal to list all. Let's put square brackets around that name just in case. And I think what we'll also do is pull out at least one of the other columns that we know that's in the packet inside the JSON that we've got here. So I think we're going to pull out perhaps that title. So I've got a piece of pre-prepared select statement to bring out that title, and I think you need to just quickly have a look at this packet and go, there's actually an array sitting in there inside the JSON. So we're going to look for the key packet, we're going to look at the first element in the array, then we're going to look for the title. What's good about JSON value is that that will return a null if there isn't a value. So let's go ahead, let's fire off that query and look at the results. So we've now got our new column title, we've got only our rows for that particular type or name of event. So this is the actual data set that we're interested in going forward. Perhaps we actually don't want the JSON context field, actually we just want the name field along with the title field. So this should be our final version. We'll just give that a whirl. Cool, our final version. So now we have that ready. Let's create a new view, because what we want to do now is take the output of this query and save our data mart ready for its consumption in Power BI or wherever it's going to be consumed. So I'm going to take that, I'm going to jump across to my favorite SQL Management Studio. So here in SQL Management Studio, I've got a pre-prepared view name, create statement, where I'm going to call this view MV transformed. So that stands for materialized view transformed. This is just a naming convention. It doesn't add anything to the execution. This is my standard naming convention. Effectively, the files that sit in this folder are our materialized view, this where clause, and this JSON value statement is a transformation in this instance. So let's run that and create the view. Let's come over here to views and refresh so we can see the new view here. Let's actually just double check that that gives us back what we're expecting. There's our 5 rows as we expected. So we're all good to go. We've now got this new view available to us to create a second additional copy to create our data mart. Okay, back to Synapse Studio, and this time back to our first pipeline we created. So we know that this transformation task actually drops our materialized view into the workspace folder. So all we want to do again is do a second copy job, and this time this is going to create our transformed car swap data. I'm going to give it a name. The tool, the pipeline tool, allows us to connect these two tasks together. So this effectively says, once this task has been completed, move on to this task. Now, just for the purpose of moving forward in the future, I'll just give you a quick insight that there is more than the success move. So you can move on in failure, you can move on despite there being a success or a failure with completion, or you can actually skip the next task. Interesting functionality to be able to build complex logic through a transformation. We're going to stick with something very simple for the moment. So we're going to stick with just 2 copy jobs, one after the other. This will only move to the second copy job if it's successful. So in this instance, so we're on this one, in this instance, there is already a data set up for car swap. However, this is the data set that we need for this one, for the original data set that was coming in. So we are going to need to create a new one. So we're back to creating a data set that's for SQL Azure. This will be our car swap transformed. And we can still use the same database connection. So the database connection can be common between the two. Now when we go to the table name, you can see our new materialized view, transformed view is available to us. So we can go ahead and we can consume that and create a data set for it. As you can see, a new integration data set has been created for us here. Cool. Again, we don't really need to worry about these settings for such a simple outcomes we have here, but let's click preview and just double check that the data that we're expecting is coming through, and it is. Excellent. So let's now move on to the sync side. So this is where we want to write the file to. So likewise, we want now a new Parquet write connection, which is a new Azure Data Lake Storage 2 connection. And we want to output in Parquet. And this is going to be our car swap transformed output. We're going to use our workspace connection, storage connection, and then we're going to browse for where we're going to store this data mart. Within the file naming convention that we're used to using, we use Surface as our data mart landing area, or a data mart exposing area. It's more about providing consistent naming and also applying different permissions. So we're going to drop that in a Surface folder. We'll just say yes to these because that's our basic configuration of where that folder is. We actually don't want it to drop directly into that Surface folder. We would prefer it to drop into a subfolder. So if we come back and edit here, we can actually add an extra subfolder in. So we can say, okay, this is going to be car swap data mart, and then we'll save that, and saving that in Synapse is committing it. So we actually no longer need that car swap out, transform out data set, so we can get rid of that. We actually no longer need that transformed piece of SQL. We've saved that into a view, so we can discard that. We'll navigate here to the Surface folder in preparation for our first run, so we can see the output here. And now we're back to our pipeline again. So everything's set up, looks like we got this set up correctly. We're going to go ahead and attempt our first run of this new pipeline. Okay, now we have everything ready. Let's go ahead and give this pipeline a run. It swapped us to the output column in this dialog at the bottom of the screen. You'll see that we're now progressing this first node within the package. And that's in progress. And that's succeeded, and we're now progressing through the second copy job in the package. And that's succeeded. So the final job now really is to go back and have a look and see what we've actually got in our Surface folder. And we have a data mart folder for car swap, and we have a file for car swap, which hopefully only includes the rows that we were expecting to receive. And it does, it only includes the rows expecting to receive. So just to reiterate or to clarify, this has been a very trivial example. There's been very few rows in this data set, but we could have a scenario where this first transformation was actually working over, say, 3 or 4 million rows. This second transformation could be grouping and summing and summarizing that data in some way. So by reducing the number of rows very rapidly, so we could have, say, for example, 3 million rows here, reduced to a data set that might have only 1 million rows in, and then we could have this transformation grouping and summing into perhaps categories, and then dropping out its final file that might have, say, a few hundred rows in, or even a few thousand rows. We quickly move from an extremely large data set, which is untenable to work with, to something that's actually strategically easy to work with. So thank you very much for your attention. I'm hoping that you got from that using some pretty simple functionality on the Synapse platform, we can achieve our desired outcome. We can build a pipeline. So we use SQL on demand to read some data from some JSON files. We ran a query over that to do a very mild filter on that data. We then saved that query as a view in the database. We then added a copy pipeline, or a copy job to a pipeline, to a new pipeline. That copy job converted that CSV data into Parquet file. It also added snappy compression to that file as well. That compacted the individual JSON files into a single Parquet file. We then effectively created a materialized view and a transformation in one inside a new view that we saved to the SQL Server, and then we added a second copy job to take the data from that view and save that as our final materialized view. And we did that across landing, our workspace folder and our surface folder. Next time we'll talk about how you can connect that material or that data mart that you've created in Surface to Power BI, and that will follow the full chain through to the very end of visualizing that data in Power BI. Thank you.